Hello again. We are going to continue with our combinations and permutations lecture. And so, as we look at it, let's of all just use the formula a little bit to see how it works. So, if we have permutations 10 and 3, what does this mean? This means I want to know how many groups of 3 I can build from a set of 10. Okay, so 10 is your n, because n is equal the total number in the set. And r, because this is n and r is equal to the number in the group that is chosen out of the set. So remembering your formula, it's permutations nr, let's write that over here. Permutations nr is equal to n factorial over n minus r factorial. Okay? So, since n is 10 and r is 3, this is going to be permutations 10, 3 is equal to 10 factorial over 10 minus 3 factorial. Well, 10 minus 3 is 7, so the denominator is actually 7 factorial. So, let's start with our 10 on top. You're going to go 10 times 9 times 8 times 7 factorial. And our denominator is that 7 factorial. So, 7 factorial cancels with 7 factorial, leaving me with 10 times 9 times 8, which is equal to 720. So we have 720 possible outcomes in choosing a group of 3 from 10 elements. So you can see how big it is. Now remember, in permutations, every single kind of a group, even though the order is different, there are still individual groups. So if I wanted to have a group that had A, B, C, for example, that order is going to appear one time. So what is the chance of drawing a group that is A, B, C out of the first 10 letters of the alphabet? It's 1 out of 720 chances. So that means we have a probability in this case of 1 divided by 720, which is equal to 0.00138, and that continues, so it's going to round to a 9. And in your book, it is going to ask you probably to carry this to 6 place values. So be sure to check where you have to round things, because most of the time in the book they're asking for 6 place values. So I rounded it to 0.001389. Now, once in a while, they will ask you for a percentage. So if they ask you for a percent, remember changing that to percent would be multiply it by 100%, which is going to give you 0.1389%. But in the probability in our textbook, in most cases, they are requesting that you leave it as a decimal. So be sure to carry it out to a decimal place value. So that gives you some practice with permutations. Now let's look at what would happen if we did a combination with this type of a thing. So first of all, let's write down the combination formula, which is a little bit different from the permutation formula. A combination formula is CNR is equal to n factorial over r factorial times n minus r factorial. Okay? So that is your formula for this. And now, remember, just like in the other one, n is the number in the set, or the full set that we're dealing with, whatever that is. If it was letters of the alphabet, it would be 26. If it's the first 10 letters of the alphabet, it would be 10. If it's the number of possible digits, it's 10 digits. If you're talking about the members in our class, that would be 6, okay? So it just depends upon what the set is. R is the number in the group that is being selected. So if I'm pulling a group of 3, then that would be my group. So let's look at combinations 10 and 3. Same numbers we chose for the other one. So if we look at that, remember your N is 10, your R is 3. So this is equal to 10 factorial over my R factorial, which is 3 factorial, times my 10 minus 3 factorial. And again, 10 minus 3 gives you 7 factorial. So I'm going to do just like the other one. We're going to go 10 times 9 times 8 times 7 factorial. Then this 7 factorial is going to stay as a 7 factorial times my 3 factorial is 3 times 2 times 1. 7 factorial cancels with 7 factorial. 3 goes into 9 3 times. 2 goes into 8 4 times. 1 just stays on the bottom. And I end up with 3 times 4 is 12 times 10 is 120. So you see, combinations has a lot fewer in the sample set than your other one. So now, what would be the chance of drawing a group of 3 where the 3 letters that were chosen were an A, B, and C? And that would be my probability of that, of choosing an ABC, would be 1 out of 700, out of 120, which, as you see, is going to be a much smaller, a much greater chance than the other one. So 1 divided by 120 is equal to 0.008333. And the 3 is repeating. So 2, 4, 6, I'll just drop my repeating and cut everything else off. So my probability on this one is 0.00833, and so that's a lot bigger a chance than the one that had 1 out of 720. So there's an example of how to use the combinations and permutations and how to calculate them. So now let's look at an actual word problem that deals with this. Okay, this one says, the race has 140 runners. How many possible outcomes for the gold, bronze, and gold, silver, and bronze? So therefore, if the first runner that came in won the gold, the second one that crosses the line is the silver, the third one is the bronze. So the first one, if I have Matt, Sally, and John were the first 3 that came in that order, that's one possible order because the medals are different. But Sally, John, and Matt is a completely different order because they were in different places. Since their places are different, the order is important. Therefore, we would use permutations to solve this particular one. So, first of all, we need to find out how many possibilities there are with 140 participants in the race. So we're going to look at permutations and 3 because there's 3 places that are being chosen. So permutations, 140 and 3 chosen. So this is equal to 140 factorial over 140 minus 3 factorial, which is equal to 140 minus 3 is 137 factorial. So I'm going to go 140 times 139 times 138 times 137 factorial over 137 factorial. These two cancel, and I'm left with 140 times 139 times 138, which is going to equal, wonder what number? Two, 6, 8, 5, 4, 8, 0. 2,685,480. That is the number of possibilities there are. So what is the probability that John and his two best friends will win first, second, and third? Well, that would be one chance if you wanted John to win first, Matt to win second, and Eli to win third. Okay, but if you just wanted those three to be one of those three places, then we've got other possibilities. So we would need to find out how many possibilities we would have with those three. So John, Matt, Eli could be in that order. I could have John, Eli, and Matt. That's another order. I could have Matt, John, Eli, and Matt, Eli, John. Or we could have Eli, John, Matt, or Eli, Matt, John. In other words, those three win the first three places, but any of those three places would be sufficient. So there's 6 possibilities that they would win those three places. So we would have 6 out of 2,685, 480. Okay? 2,685,480. So 6 possibilities out of that would have one of those three placed in the first three positions. Now, that is equal to what? Let's see. 6 divided by 2,685,480 gives you to the negative 6. So 1, 2, 3, 4, 5, 2, 4, 6. There it is. 1, 2, 3, 4, 5, 6. Yeah. Okay, that's the probability that these three would take the first three places. But what if I said that John had to take first place and one of the two could take first and second place, the second and third place? Well, we only have 2 possibilities where John is first place. So now this would be 2 out of 2,685,480 possibilities. So again, that's going to be even less. So 2 divided by 2,685,480, and that gives us 1, 2, 3, 4, 5, 6, 7. Okay? Even less of a chance, much less of a chance than in the first one. So you see, the probability of this is really an interesting study, and that a permutation will give you the number of possibilities of a group of 3 out of 140. But then you have to look at if there's any other requirements that you have. Okay? So there it is. Probability with a permutation. Now let's look at one with a combination. We'll do one more with a permutation. How many different ways to arrange the contestants in a talent show? There are 15 contestants. So again, the order in which they're placed is important because every order is different. So therefore, we're looking at permutations 15, and we're choosing 15 because all 15 have to be placed. So this is going to be 15 factorial over 15 minus 15 factorial. And this is 0 factorial. 0 factorial by definition is always equal to 1. So keep that in mind. 0 factorial equals 1. So this ends up being 15 factorial over 1, which would be 15 times 14 times 13, etc. But there is a real neat device on your calculator. On my calculator, the Casio, right up here at the top is an option to ask for x factorial. So I am going to type in my number and shift and hit that factorial symbol. And I don't know if you can see it, but it actually showed up. And we're going to hit equal, and it's going to give me what it is. So what is the number of possibilities? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because it's such a big number that it gives it to you in scientific notation. So 2, 4, 6, 8, 10, 12. That's a really big number. Let's see. Hundreds, thousands, millions, billions, trillions. 1,307,674,368,000. That's how many different ways 15 people can be arranged into a seating formation. That's huge. And now we're talking, that's a 3 trillion, that's a huge, huge number. If you look at it, it's great big. Okay, so now let's look for one that deals with a combination. If I can find one. Let me see if I can find one. Oh, here's one. Okay, here's one. How many different sandwiches are possible if there are 18 different toppings? Okay, so 18 is my n, and the customer is going to choose 4 of those toppings for each sandwich. So the order of the choice is not important. So if we have ham, turkey, cheese, and lettuce, it doesn't matter what order those 4 things are chosen. So this is a combination. So we're going to have combinations 18 and 4, which is equal to 18 factorial over 4 factorial times 18 minus 4 factorial. Okay? So let's write that thing up. 18 minus 4 is 14 factorial. So my top, we're going to write 18 times 17 times 16 times 15 times 14 factorial over 4 times 3 times 2 times 1, taking care of the 4 factorial, multiplying it times your 14 factorial. The 14 factorials cancel out. And let's see, I've got 4 times 2 is 8, and 8 goes into 16 2 times. 3 goes into 15, well, let's do 18. 3 goes into 18 6 times. So I'm left with 17 times 15 times 6 times 2, which is 12. So let's see what that is actually equal to. 17 times 15 times 12. And we have 3,060 different sandwiches that we can make with choosing 4 toppings out of 18 possible toppings. So as you can see, a sandwich shop could make a big deal because they have a lot of choices. And people like to have things different, so choices are pretty important. And so there you have it, combinations and permutations. And we're going to do one more video in this.